Hey everyone, and welcome. Have you ever looked at a graph heading up and thought, how could I just flip that completely upside down? Well, in algebra, it's actually way easier than you think. Today, we're going to flip the script, literally, and dive right into the world of reflections.
And this right here, this is pretty much the main idea for this whole explainer. I mean, think about it. A mirror gives you a perfect reversed image, right? Well, in the world of math, one little negative sign has that exact same power. It's our mathematical mirror, and we're going to see exactly how it works.
So here's our game plan. We'll start with the big idea, the mirror in math. Then we'll get into the one rule you really need to know. After that, we'll see it in action with some examples, I'll point out a few common mistakes to avoid, and then we'll wrap up by talking about why any of this actually matters. Sound good? Let's go.
Okay, first up, the mirror in math. We're going to take that simple idea of a looking glass and see how it translates perfectly to the lines and curves that we work with on a graph.
So what even is a reflection in algebra? Well, it's exactly what it sounds like. We're creating a perfect mirror image of a graph across a specific line, which we call an axis. For today, our focus is going to be on flipping graphs over the horizontal x-axis. A great way to picture this is to imagine your graph is just staring down at its own reflection in a perfectly still lake. All right, now for the main event, the core reflection rule. This is the how-to, the one super simple, super powerful trick that lets you flip pretty much any graph you come across. And believe it or not, it all boils down to one tiny symbol.
And here it is. The new function g of x equals negative f of x. All this fancy notation means is that you take your original function, whatever it is, and you multiply the entire thing by -1. That negative sign right out front, that's your flip switch. And I can't stress this enough. It applies to the entire function. That's the most important part.
And this is what happens when you hit that switch. Any part of the graph that was up top, in positive territory, gets flipped down to the bottom, into negative land. All your positive y values become negative y values. It's that simple. What was up is now down. A perfect vertical flip.
So, the theory is cool and all, but let's actually see this thing in action. It's time to get our hands dirty and walk through a few step-by-step examples. This is where it'll really start to click. Let's start with a nice, easy one. Our function is f of x equals 3x. So this is just a straight line going through the origin with a positive slope. It's heading uphill. So, how do we flip it? Okay, let's break it down. Step 1, we just apply our rule. We stick a negative sign right in front of the whole function. So now we have g of x equals negative 2 3x. Step 2, we simplify that, which just gives us negative 3x. So what happened? The slope completely flipped from positive 3 to negative 3. The line that was going uphill is now going straight downhill.
All right, let's ramp up the difficulty just a little bit. Our next function is f of x equals x plus 2. See, now we have two separate terms to worry about. This is where that whole multiply the entire function rule becomes so important. Now look closely at step 1 because this is the key. You have to use parentheses here. We write negative, and then in parentheses, x plus 2. This is our visual reminder to distribute that negative to every single thing inside. So the negative hits the x, giving us negative x. And then it hits the positive 2, giving us negative 2. Our final reflected function is g of x equals negative x minus 2. And check this out. Not only did the slope flip, but the y-intercept also flipped from positive 2 all the way down to negative 2. Okay, for our last example, let's get a little tricky. What happens if you try to reflect a function that's already negative? Something that's already pointing downhill. Like f of x equals negative 2x minus 5. We just follow the exact same rule, no special tricks. We put a negative sign in front of the whole thing. So we get negative, and then in parentheses, negative 2x minus 5. And we all know what happens when two negatives get together, right? They make a positive. So negative times negative 2x becomes a positive 2x. And negative times negative 5 becomes a positive 5. Our final result, g of x equals 2x plus 5. We actually flipped a downhill line and made it go back uphill. All right, so you've seen how to do this the right way. Now let's switch gears for a second. I want to act like your coach and point out a couple of super common mistakes, these little traps that are really easy to fall into. This right here is, without a doubt, the #1 mistake people make. They see something like x plus 5, and they just flip the first part, so they write negative x plus 5. No, that's wrong.
you forgot to distribute the negative. Remember, that negative sign is the flip switch for the entire function, which means it has to apply to the x and to the 5. The correct answer is negative x minus 5.
The second trap is getting two different kinds of reflections mixed up. Putting the negative outside the function, like we've been doing today with negative f of x, flips things up and down over the x-axis. But there's a whole other rule, f of negative x, where the negative is inside with the x. That one flips the graph left and right. So just remember, negative outside means a vertical flip, negative inside means a horizontal one.
So why are we even learning this? Is this just some random math trick? No, absolutely not. This idea of reflections pops up all over the place in the real world, especially when we want to model things that are opposites.
And here's a perfect example. Business. Imagine you have a function, let's call it p of x, that shows the profit your company is making over time. Well, what would model your company's loss over that same period? You probably guessed it. It would be negative p of x. It's the exact same curve, the same financial trend, just flipped upside down across that break-even line.
And this just nails the point home. Making $100 and losing $100 are total opposites from a financial standpoint, right? But mathematically, they are perfect reflections of each other around zero. The same idea we use to flip a graph is used to flip an outcome from a gain to a loss.
Okay, let's do a super quick recap of the most important stuff. A negative sign out front flips your graph over the x-axis. The big rule to remember is g of x equals negative f of x. And please, 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 always remember to distribute that negative times every single term. And finally, this isn't just about lines on a page, it's a powerful tool for modeling opposites in the real world. So we've totally mastered flipping graphs up and down, which leaves me with one final question for you. If putting the negative sign on the outside of the function flips it vertically, what do you think would happen if we put that negative on the inside? Just something to noodle on. Thanks so much for joining me.